Well, as Sherry comes up to the stage, we're going to kind of get everybody situated and get started. We are very excited to have this program here tonight. We're not on virtual, but we're appreciative. Martin County TV, MCTV is recording it. So we will have the recording of this program to put on our website and just send around and have on other websites so everybody can get a chance to kind of catch all this background of what's going on. I do appreciate Martin County, the Library Association, for letting us have the facility and being able to record it tonight, so we really appreciate that. I just ask all, if you have cell phones, which we all do, right, if we can have them on silent, so just in case during the presentation we don't have somebody's phone ringing, which would actually, you know, be okay. If it's an emergency, you need to take it, fine. But we appreciate you coming tonight. My name is Mark Perry. I'm the Executive Director and CEO of Florida Oceanographic Society. Have any of you been out to the Coastal Center on Hutchinson Island? Yay, okay. Thanks. We just opened up a new exhibit called Waterworks Exploration Zone. It's really a great exhibit. And we're open out there for visitation, and we encourage you to come, bring some friends, your family. It's a really fun place to be. You'll learn a lot out there. We have a 750,000 gallon game fish lagoon with all a bunch of new fish and sea turtles and everything. So it's a great place to come and learn and get excited and inspired about, you know, protecting our Florida's coastal ecosystem. So tonight we're talking about a particular coastal ecosystem, and I want to appreciate our staff to help put it together with me is Valentina Miele. She's our advocacy coordinator. She helps me to do the research and coordinate all the advocacy situations that we do. We attend a lot of meetings, go to Congress and the legislature and try to convince them and educate them about the issues and do a lot of stuff. So I appreciate Valentina. Also with me tonight is Michelle Byreal. Michelle is there at the table, and we got great information back there. So if you're on your way in or out, be sure you check out the petitions, check out the information. And coming up here on stage is Sherry Anker. She's going to join me as the president of the St. Lucie County Conservation Alliance. Sherry's coming up. So our job tonight is to kind of introduce you to two fantastic scientists who have gone to the deep. They've gone to the deepest parts to explore for us so that they can share with us their knowledge and expertise on this particular reef. It's called Dragging the Deep, and the reason is it's a particular reef that's offshore. It goes from Fort Pierce out to Daytona Beach. It's roughly about 135 miles long, and it's colored in there on the graph on the left-hand side of your screen, and we also have it there. But that reef is designated in that color because it's a marine protected area. And the scientists with us tonight have worked on this for a long time to discover why it's so important. And back in the 70s, actually, and then back in the 80s, they actually were working to they were working to discover not only the beauty of this reef and how incredibly diverse it is in all the system, but it's in a deep water. It's below the scuba depths, 300 feet, where the pressure is about 10 times what it is right around you right now. The atmospheric pressure right now is about 14 pounds. It's about 140 pounds per square inch down there. So you really have to lockout dive. You have to do special diving. They're in their submersibles on those two photos that you see there. So it's really an incredible reef system that we're going to talk about and learn about, but it's also under pressure. But when it was designated as a habitat area of particular concern back in 1984 by NOAA and the South Atlantic Fisheries Management Council, it's now being proposed to have an amendment to it that's going to open up some of that area to what we call rock shrimp trawling, and that trawling activity is very detrimental. That's why we're titled this talk, Dragging the Deep. So we're going to talk about the Oculina Reef, and I want Sherry to kind of give us some history here.
Thank you, Mark. I come from the Conservation Alliance of St. Lucie County, and these two wonderful scientists here worked with Harbor Branch and did the preliminary research to establish that this coral reef existed at all. And we are profoundly, as an organization that has conservation in its name, we're profoundly honored that these two gentlemen serve on our board. In 2020, Professor Reed alerted us to the proposed Amendment 10 by the South Atlantic Fishery Management Council. If it adopted, it would alter the Oculina Coral Reef's habitat area of particular concerns, conservation status, and its boundaries. The one-of-a-kind, truly magnificent deepwater coral reefs ecosystem hosts over 2,000 species. Professor Reed and his Harbor Branch colleagues had discovered, heavily researched, and finally achieved that protective legal protection in 1984. The world's first marine protected area for deep water corals was established. Meanwhile, in the 1970s and 80s, ichthyologist Dr. Grant Gilmore extensively studied the fish species that were dependent in one way or another on Oculina coral reef as a keystone species, as well as its connection with the Indian River Lagoon. This information will be gone into much more depth when the two wonderful scientists will be coming to speak in length about what they have studied and found. So once we were alerted by Professor Reed, we went into high gear and produced the first petition. Then Professor Reed brought in Mike Gravitz of the Marine Conservation Institute in Washington, D.C., which subsequently greatly aided the organization of our defense. Dr. Gilmore alerted Sylvia Earle, famed oceanographer who had worked with Dr. Gilmore on Oculina. If you make sure you get a chance to read her profound and succinct statement that we produced on a poster here, it says it all in that very brief paragraph. She says everything that's important to know about where we are with Oculina. The plight of Oculina received press and TV coverage from here to North Florida to the Washington Post. The petition numbers now were at more than 40,000. Local and national organizations and scientists like Dr. Edie Witter of Orca, as well as, of course, Mark Perry and Florida Oceanographic Societies, registered their opposition to such an unfathomable destruction of a just discovered Oculina coral ecosystem by bottom trawling shrimpers. Public comments received by NOAA registered over 33,000, with the vast majority opposed to Amendment 10. In July of 22, the National Marine Fisheries of NOAA disapproved Amendment 10. Yay! Unfortunately, a small window was left open for the bottom trawling shrimpers to reapply. As former fish reporter for TC Palm, Ed Killer, predicted, they will try again, and they did. Of course, politics are involved, but we'll save that for later. So here we are with the new version of Amendment 10, now titled as Amendments 11 and 12. The Council approved their passage again, and that has been sent to NOAA to make the final approval. We may have news in just a month or two. Thus, we're reassembling and have attended the council meetings and provided our public comment. The Indian River keeper, Gilmore, has joined our core group as well. We're thrilled for the expanded commitment by Mark Perry and FOS to erect a campaign. Our strategy is evolving to mount an offensive that cannot be overcome. Stay tuned and be at the ready. Thank you.
All right, thank you, Sherry. Yeah, that marvelous introduction. I'm kind of honored, just like the picture is here, to be in between these two incredible scientists, John Reed and Grant Gilmore, whom I've known for many years. Not all the years that they've been dedicated to their profession and their science, but John Reed is a research professor emeritus at Harbor Branch Oceanographic Institute. He has nearly 47 years in his research and conservation efforts as a pioneer, basically, in the deep water and coral reef research and conservation. John is since 1976 in Harbor Branch Oceanographic, studying deepwater Oculina and Lophelia coral reefs. He was instrumental in establishing the 300 square mile Oculina Coral Marine Protected Area, but also up and down the coast, deepwater coral habitats area of particular concern, not only around Florida, but all the way up to North Carolina. Over 23,000 square miles. He was instrumental in helping to get those under protection as well, or at least considered. He's chief or co-chief of scientists on 60 research expeditions in 40 different countries. I want you to think about that. 60 deep water expeditions down in those submersibles, lockout diving under pressure to study these deep corals in 40 different countries. John has just been incredible, hundreds of publications, done all these science and articles and work, and has been recognized as a faculty emeritus with Harbor Branch and FAU, but he's also been recognized as leaving a legacy of protected reef, these deep coral reefs, and has been doing that advocacy even after his basically work with Harbor Branch. So give it up for, thank you, John. It's going to come up and start us off. John will kick us off, but I'm also surrounded by Grant Gilmore. Grant has been with us for many years as well, over 50 years of marine research. Grant's done all the tropical Americas, studying primarily his principal research efforts, of course, are on tropical and subtropical freshwater and coastal ocean fish. The biology, ecology, the morphology, the taxonomy of thousands of different types of fish, and he's always impressed me that he's so excited when he finds even a species he's seen before, but it's just like, wow, it's here and it's there, and it's fantastic. I've been on many expeditions with him. His ecology and his study of these assemblages in habitats like mangroves and seagrasses is just outstanding. He's done a tremendous amount of work in acoustics, basically studying the sounds underwater and the propagation of sounds by spawning aggregations of spotted sea trout, for instance. I've been with him in our estuary here in St. Lucie estuary for many a nights. We've put the hydrophones over and listened for those spawning aggregations. And it's an incredible science that he's been involved with. From 1987 to present, he's done 20 national and international kind of television documentaries. He's worked with, of course, National Geographic, Discovery Channel, Fox, NPR programs. The list goes on and on. Grant when he left Harbor Branch for many years, he was there 27 years, from 71 to 1998, but he set up his own group of exploring the estuary, coastal, and ocean sciences. And he is still in Vero Beach, and he's still working, diligently to help protect and preserve these ecosystems. Again, just like John has many, many publications, many scientists around. I'm just very, very honored to have them both here tonight and to help us all learn more about these reefs and learn how we can protect them and get going. So John, come on up. I'll get you started on our first one. So give it up for John Reed.
Could we get these lights off? Because it really
Okay.
I don't need to be in the light.
Yeah, okay. We'll try to get the lights turned off so it can better show the screen. And get back up to...
Well, first off, I want to thank Mark Perry and FOS for hosting this and allowing Grant Gilmore and myself to speak and tell you about these deep water reefs that truly they only occur here and nowhere else on Earth. And we need to be better stewards taking care of them. So I urge all of you when you leave, sign that petition in the back to let your congressmen and different people be aware of what's going on here. So let me try to drop those out. Yeah, okay. So my talk is primarily to tell you about the reefs. What are these deepwater Oculina reefs? How were they discovered? What type of research has been done on them, as well as what are we doing now to try to protect them 45 years later where they're still under pressure for development. So this is an aerial photograph off North Beach, Fort Pierce, before most of the high-rise condominiums got built. But if you look out in the water, you see those dark lines. And it's not coral reef, but that's hard bottom habitat. It's rocky ledges that act like a coral reef. And these ledges formed when sea level was about 300 feet lower than it is now. 15,000 years ago, the beach was about 15 miles offshore here. As the sea level rise, it'd come up and stop a while and erode into the ledges. So you have these hard bottom communities that 90 foot deep, 60 foot, and inshore at 15 feet. But they do provide habitat for all kinds of fish and invertebrates, just like a coral reef. This is right off Fort Pierce. There we go. It provides habitat for lobsters, thank you. Fish, I don't know where I'm supposed to point with this, probably over here. Big eyes. These are soft corals. So this hard bottom community acts like a reef. It provides habitat for all kinds of animals. But in shallow water, 15 to 30 feet, you get these small heads of Oculina coral, and here's one right here, the deep water form. In shallow water, the coral is golden brown because it has algae growing in the coral. And it's, of course, impacted by fishing lines and all kinds of stuff. And this is a close-up of Oculina. Oculina, if you see these little oval features, that's where the animal lives. And the animal has 6 tentacles that grabs plankton. Well, within the tissue of the animal is algae called zooxanthellae. And all shallow water coral around the world have that symbiotic relationship. And this is a close-up of it. You can see these little somewhere. There we go. Those are the tentacles, those little dots, those zooxanthellae. And I'm sure many of you have heard of coral bleaching. So all tropical corals around the world have the symbiotic relationship. If the coral becomes too stressed, it will eject the zooxanthellae and become white. And that's a photomicrograph of the zooxanthellae. They're very small, but they're algae. So the algae is producing oxygen that the animal utilizes, and the animal's producing carbon dioxide and waste products that the algae uses. So if a coral becomes white from bleaching and doesn't get the algae back soon enough, it will die. There's coral bleaching occurring around the world because the temperatures are getting so warm. Well, what's truly amazing is this coral is one of a few species that is able to live without zooxanthellae. So in shallow water it has it, in deep water it is pure white. And it grows down to 300 feet or more deeper. So once you get over about 150 feet, 200 feet, the coral loses its zooxanthellae and becomes pure white, or azooxanthellae. This might be the future of coral reefs as all the shallow water reefs die off. If we could figure out how does this coral survive without zooxanthellae, it would be a huge, huge discovery. So the actual coral grows throughout the Caribbean, but only makes these deep water reefs off of Fort Pierce to Daytona Beach. So as you go offshore, right at the shelf edge break, 300 feet of water, you have these 100-foot tall mounds of coral that have built up over the last 1,000 years or more. And these are transects. As you come offshore, the bottom transect is off Fort Pierce, the top one off Cape Canaveral, and right where the bottom drops at the shelf break, you see these pinnacles, and those are the Oculina pinnacles. And in shallow water and deep water, 200, 300 feet deep. These coral colonies grow up to 6 feet tall, the size of an SUV. This is what they looked like in 1970s when we discovered the reefs, 1980s, and then unfortunately by the 90s, 2000, large swaths of these reefs had been destroyed primarily from bottom trawling. So this is how we first discovered them. We were doing surveys with our submersible Johnson Sea Link sub from 100 feet to 1,000 feet, and each little dark line was one sub dive. So it took about 2 years to survey out there. Nobody knew anything about it, what lived out there. So during these surveys from 100 feet deep to 1,000 feet deep, we discovered these deep water reefs in that boxed area. This is we had 3 ships at Harbor Branch Oceanographic Institute, and the ships carried the submersible 4-man sub. The front of the sub was an acrylic sphere, 6 feet in diameter, that you had the pilot and observer sitting in. So you had like a 180, 270-degree field of view all around you. It had collection gear, camera systems, and the back of the sub was a dive chamber. So the first studies I did, nobody knew anything about these deep water reefs. It was what lived there, what animals live on these deep water reefs, how fast do they grow? And we found it was very biodiverse, 70 species of fish, mollusks, crustaceans, amphipods, echinoderms, and these are food for all the fish out there. So 70 species of grouper that Dr. Gilmore will talk about. And in the 70s and 80s, it was just covered with fish. Scamp grouper, gag grouper, snowy grouper. And what's really cool is some of these grouper, like the scamp and gag, go to the deep reefs to spawn. And then the baby fish come up from the water column, and some of them come inshore 15, 20 miles away and come into the jetties along the coastline and end up in the grass beds and mangroves of the Indian River Lagoon. So these deep water reefs are connected to the health of the grass beds of the lagoon. We destroy the grass beds, we're going to affect the deep water coral or deep water fish also. Big schools of amberjack. That was about I don't know what he was, 300, 500 pound Warsaw grouper. This is about an 8-foot mola mola, ocean sunfish. So one of the first studies I did, what lives on the coral? So I made this mesh bag, put it over a coral head, small coral head, and collected everything on and in it. And it was just an amazing, diverse community of all these animals. And it's neat. We put a time-lapse camera on them, and during the day, all these animals hide inside of the coral. And at twilight, all of a sudden, they start coming out on the branch tips feeding. "230 species of clams and snails." This is a squid. We have 50 species of decapods. Decapods are crabs and shrimp. So all of these are living in the branches and food for the fish. Snapping shrimp is a little tiny lobster. Most of them are pretty tiny. And so we also studied the physical environment. So we had temperature recorders on the bottom for a year. So we know what the bottom temperatures are. We know what the currents are on the bottom. And some of the nonsense that comes out of the shrimp community, the rock shrimp community, and the South Atlantic Fishery Council saying, oh, the currents only go north. No, they go west. They go west during upwelling events. Any trawling is going to put that sediment right on the coral reefs. We see the salinity stays high year-round. That's almost pure salt water. Another example or argument the shrimp trawlers give is, oh, all the dead coral is because of the water coming out of the St. Lucie Inlet and all the different inlets. No. You get most aerial photographs showing the water coming out of the St. Lucie Inlet goes to the south along the coastline. But even if it did go offshore, it's not getting to the bottom, not at 36 parts per thousand. That's pure salt water. It's staying on the surface. It's not affecting the reef. John Holt, major engineer at Harbor Branch, is the time-lapse camera he made. So we put these instruments on the reef as a temperature gauge and a current meter. And here we can see these upwelling events. The bottom line, the bottom graph is 80 meters. That's the deepwater reef. And every time the bottom temperature drops down like that, that's an upwelling event. An upwelling event occurs when the cold bottom water in the Straits of Florida pushed up on shelf and pushing the bottom water to the west. Now, inshore, your inshore reefs only get that cold water upwelling in the summertime. You can see here that upwelling occurs throughout the year on the deepwater reef. So any trawling the shrimpers want to do just west of the reef, or east of the reef, this bottom water pushing up will push that sediment onto the coral and impacting the coral larvae too. So this is how we did our experiments. We did lockout dives where we would pressurize the sub and dive out the bottom. And this is where I studied the growth rate of the coral. So I found out that the coral grows very, very slowly, less than a half an inch a year. So a 6-foot size coral head, like an SUV size, would be well over a century old, very slow growing. And that white, so I stained the coral pink with alizarin dye, and the white is a new growth after a year, and is growing about 5 millimeters a year. So what are the main impacts? Primarily from humans. From the worst one, of course, is bottom trawling, dragging a net over the reef, hard to believe. Bottom long lines, and fish traps, and anchoring. So those nets, on the end of the nets are these heavy doors, weigh about 1,000 pounds, that spreads the net apart and is dragged along the bottom. And the shrimpers told me how they did it. They would take the nets off, go to an area, drag the bottom with the chain, knock down the coral, so it's just rubble. The rock shrimp love rubble, and then go back with the nets to collect the rock shrimp. Hard to imagine. Of course, they said, we've never done that. Then how come your nets are on the bottom? This is a coral reef off Cape Canaveral. I took a picture about 1978. There's one single pinnacle out there, so I know that pinnacle. There's only one pinnacle like that, covered with that big bush of coral. That's about 20 feet from top to bottom. This is the same reef, the same peak. several years later, 1980s, nothing left, no habitat. Of course, they said, well, we've never done that. Well, this is a newspaper article where the Coast Guard confiscated a rock shrimp boat that was fishing right off Fort Pierce, right in the heart of the original protected area. They brought them into shore. They found a huge chunk of coral hidden in the smokestack. They called me up, and I came down to the port and discovered, yes, it was Oculina varicosa that they had collected during their trawling. So what's the big deal? Well, this is how much coral damage occurred between early 1980s and about 1990s. Major loss of coral. And what's the big deal about loss of corals? Instead of a nice coral head, you have rubble. Well, if you have rubble on the left part, the unconstellated rubble, there's no habitat. There's no scamp grouper on that rubble reef. An intact reef, you can see the numbers of scamp and grouper that live out there. So what are we doing here? Originally, I nominated these reefs to be a marine protected area. 1984, the Oculina habitat of particular concern was designated. It was the first deepwater coral reef in the world to protect a deepwater coral reef. And all this bottom gear was banned, so trawling was banned. 2000, we got it extended up to Cape Canaveral. In 2016, up to Daytona. So that's the entire extent of these Oculina reefs from Fort Pierce to Cape Canaveral, up to Daytona. So this little bottom square is the first area that was protected. And I've had to fight the shrimpers tooth and nail to get that the South Atlantic Fishery Council didn't want to protect it all the way up to Cape Canaveral. They said, well, you don't have enough data. Well, I have the same amount of data. All those transects were dives we made. So 1984, only protected from Fort Pierce to Sebastian. Not until 2000 did I get it protected up to Cape Canaveral. So in that time period, from 84 to 2000, this was all open to trawling. And they did a number on it. So in 2016, I knew the reef had to extend north of Cape Canaveral, and we had just looking at the bathymetric charts, you could see the squiggles at the bottom that showed high relief. I had an ROV survey in 2016 with NOAA Fisheries, and each of the little circles is a reef, a high relief reef, maybe 100 feet tall, and that's a multi-beam of it. So we drew the protected area line. That red line is the eastern border that I drew at NOAA Fisheries at the South Atlantic Council. We said, okay, we need to draw the eastern border up there just to the east of the high relief features that we know are coral. So we put it out at 100-meter depth. It's very, everybody agreed on that number, 100-meter depth. The Coast Guard agreed, said it'd help keep poachers out. It would help them to control illegal poaching and fishing in there. And then later on, so it wasn't, it was right at the base of the reefs where we put that border. It wasn't extravagant. So since 1985, any of the HAPC had no bottom gear. You control, but not bottom gear. 2016, they went up to Daytona. 2022, the rock shrimpers proposed Amendment 10 to allow them to fish right up to the reef up there in that northern portion. And thanks to the South Atlantic, Sherry Anchor and the Conservation Alliance, they put a stop to that. So why open up trawling within the HAPC after 40 years? So 2025, after Amendment 10 got shot down, they came back with just a renumbering with the same amendment, Amendment 11 and 12, to allow shrimp trawling within the Oculina HAPC along that eastern border, but within the border, within the protected area. So right now it's under review by NOAA Fisheries, the Amendment 11 and 12. And this is part of the amendment. This is written in the amendment. At its 2025 meeting, the South Atlantic Council decided not to convene its advisory panels to review the amendment. So essentially they said the Coral Advisory Panel, the Coral Advisory Panel are the people that are most knowledgeable about deepwater reefs. They were not allowed to vote or to speak up about the new amendments, Amendment 11 and 12. They were banned from the vote. Is that unbelievable? Part of the council that they knew would be against it said, well, you can't vote for it because you already voted against Amendment 10. So the members of the Coral Advisory Panel have more knowledge about deepwater coral than any other on the South Atlantic Fishery Council. Dr. Sandra Brooke is a vice president of the Coral AP, did her PhD dissertation on the reproduction of deepwater Oculina and knows how fragile those little tiny coral larvae are. Sedimentation will kill them. Is this legal? I don't know. It's certainly not ethical what they did. So in conclusion, I urge all of you to sign that petition in the back, that it'll be sent to various departments of federal agencies, state agencies, just stating no trawling within any part of the OHAPC. So I want to thank Mark Perry and FOS for hosting this, and certainly thank all the other organizations that have been a big part of this. Marine Conservation Institute, Indian River Keeper, Center for Biological Diversity, and the Florida Oceanographic Institute. And a special thanks to the Conservation Alliance, St. Lucie County, and especially Sherry Anchor, the director, who were instrumental in starting and winning the fight against the proposed Amendment 10. So now we've got to keep fighting this Amendment 11 and 12. And I'm going to switch over to, I have a video that we made. It's a documentary that we made a while back with the summer intern I had, my videographer, and it shows what the reefs look
like. Hidden 300 feet below the ocean waves, just 16 miles off the Florida shoreline, lies a mystical and fragile treasure. For centuries seen only by the fish and other creatures that inhabit it. The only humans aware of its rich diversity of life are the scientists studying these unique reefs and the fishermen that trawl this delicate ecosystem to destruction. Using the Johnson Sea-Link manned submersibles and a remotely operated vehicle known as CORD, scientists from the Harbor Branch Oceanographic Institution discovered the deepwater Oculina reefs in 1975. These eerie white coral reefs are found only off the coast of Florida and nowhere else on Earth. They are entirely composed of a single species of coral, the ivory tree coral, Oculina varicosa, that can build reefs up to 100 feet tall. The deepwater Oculina reefs are similar to their shallow water cousins with one distinction. The deepwater Oculina corals lack zooxanthellae, microscopic single-celled plants that live inside shallow water coral, converting sunlight into food, a biological process known as photosynthesis. Deep Oculina coral capture plankton and nutrients from the rapidly flowing Gulf Stream. The Oculina reefs are located 200 to 300 feet below the surface, anywhere from 16 to 50 miles offshore. When the Harbor Branch submersibles first dived on the reefs in the mid-1970s, scientists aboard witnessed an unexpected diversity of life located on and around the Oculina reefs. A special form of diving known as lockout diving, when a diver actually swims out of the JSL submersible, allowed scientists like John Reed to study the Oculina reefs firsthand.
Back in the 1970s and early 80s, we used lockout diving, where we're actually tethered to the sub and breathe a spatial gas mixture of helium and oxygen. And we use this to dive down to 300 feet deep. This allowed me to do most of my experiments that I couldn't have done otherwise, such as studying the growth rate of the coral and studying the community of animals that lived within the coral.
When he examined a small Oculina coral colony, merely the size of a soccer ball, he discovered that this little Oculina castle was home to over 2,000 little animals, including hundreds of species of worms, clams, snails, crabs, and shrimp that had bored or crawled into the coral habitat. Many more dives were made on the reefs throughout the 1970s and into the late 1980s. In turn, more Oculina mounds were discovered, reaching as far north as Cape Canaveral and as far south as Fort Pierce. Unfortunately, in some places where the scientists expected to find a beautiful living and growing coral mound, they discovered only rubble. Tiny pieces of the fragile Oculina littered the seafloor, and the vast schools of fish that usually swam along the reefs had vanished, along with the legions of smaller invertebrates. Deep cuts were carved into this abandoned ghost town of broken coral. Could these be a clue to the cause of the coral's destruction? Complete reefs were decimated by bottom trawlers, destroying in a single moment what took centuries to build. Fish that do escape the trawl's gaping mouth are left without the nooks and crannies the coral provided as shelter. In addition, their food source has disappeared into the nets. Bottom trawlers capture thousands of fish and shrimp in a single trawl, but destroy the reef in the process. In search of more catch, the trawlers move from reef to reef, leaving behind ruins. In 1984, the South Atlantic Fishery Management Council recognized the importance of the Oculina reefs, designating a 92 square mile section as the Oculina habitat area of particular concern. This area was closed to trawling, dredging, and longline fishing. Unfortunately, only the southern half of the reefs were located within these protected boundaries. The northern half, left unprotected, remained vulnerable to destructive fishing practices. Scientists noticed a dramatic decrease in fish populations as they dove on the reefs in the 1990s when compared to the 1970s and early 80s. Once, dense schools of scamp and gag grouper formed spawning aggregations over the living reefs, and large groupers, over 200 pounds, were common. Schools of amberjack were so thick that scientists would lose sight of the reef just 10 feet in front of the sub. By 1994, those vast schools had been virtually depleted. Overfishing and the damage it caused had taken its toll. So in 1994, the South Atlantic Fishery Management Council went a step further and closed the original 92 square mile reserve to all bottom fishing for at least 10 years, creating the first marine protected area in the United States. The council wanted to see if fish populations could increase and bring back the previous levels of spawning aggregations. The reefs near Cape Canaveral were carefully documented in the 1970s and 80s using photography and video. Submersible transects of the reef were remade in 2001, clearly showing the devastation after 20 years of unrestricted trawling activity. Scientists have deployed several man-made devices to help the Oculina coral grow by giving them a stable foundation. Artificial reef balls and reef blocks were placed in the late 1990s and 2000s. Deep-sea research has shown that the Oculina will grow on these artificial surfaces. However, Oculina, like most deep-water coral, grows very slowly at a rate of only about ½ an inch a year. A large colony the size of a Volkswagen Beetle could easily be over 100 years old. In 2003, the Oculina Marine Protected Area, which prohibited bottom fishing on the southern Oculina reefs for the previous 10 years, was extended indefinitely. Recent research indicates that the fish are slowly coming back. Jeff's Reef, located in the protected zone since 1984, is an example of one reef that has flourished. Oculina corals grow surrounded by sea urchins and schools of amberjacks, groupers, and others. This reef is proof that the Oculina corals are not yet a lost treasure, but rather a prize buried in Florida's very own backyard. With careful management, this treasure will prosper and thrive for generations. In 2000, the Oculina habitat area of particular concern was further expanded to 300 square miles, protecting the majority of the known deepwater reefs. Thanks to the efforts of scientists and forward-thinking legislation, the Oculina Reef's national treasure has not only survived, but is continuing to grow.
Let's give it up for John. Thank you so much, John. Appreciate you. And we'll kind of go into our next round. John, you want to say? Sure. Here you go.
When we made that documentary, that was before amendment to the two amendments came up in the last few years. So we didn't include in the documentary, but oh yeah, by the way, the shrimpers are trying to get back in again. So we'll have to make an amendment to the amendment.
As I said, as Grant comes up, we're just really privileged to have both of these scientists here. Grant, come on up. We're going to cue up his section of the program and then have some questions and answers and get them both up here. But Grant's been doing this for many, many years, and particularly right here in our own backyard area. And I'm just so privileged to have you with us tonight, Grant, and thank you for coming.
John, I might add, well, first of all, the Harbor Branch Oceanographic Institution that we both worked at was dedicated, when it was founded, to getting humans underwater. And of course, in those days, we thought we would be living in villages underwater. And we also thought we were going to be living on the moon, right? And going to Mars, a few other places. We found out the human physiology really wasn't meant for that. Although John, if you look closely at his neck, he's grown some gills. He actually has done more lockout dives than anybody else out of that submarine. And we actually had people that block out at 800 feet, and then we were all guinea pigs. We're all guinea pigs when we started out there. And so what you're seeing is two old guys trying to get you to protect part of this earth that we've been living on for over 50 years. John and I have been out in the ocean all this time, and my part of the talk is to talk about the fish out there, the animals. And I want to introduce you to these guys because they're really interesting. I wanted to introduce you to these guys. And I'm writing a history of Harbor Branch. These are the three individuals that founded the institution. On the left is Seward Johnson Sr. of J&J Pharmaceuticals. He funded it. In the middle is Edwin Link, who designed and invented the submarine. Then all the scientists at Harbor Branch were hired by Gene Wallen of the Smithsonian. The Smithsonian hired, there would be no scientists at Harbor Branch who weren't for the Smithsonian Institution. And after him came Dare Feldman, who also hired. Well, when this photograph was taken, I was being interviewed by Wallen to start there. This is 1971. I actually began there in 71 with Doug Putnam. We were the two first employees of Harbor Branch. And I was told in that interview, that you'll agree to lock out at 500 feet out of the submarine. So, oh, sure, you know, everybody's going to live underwater one of these days, sure. I changed my mind a little bit later, but anyway, the institution was founded by these guys who had a lot of curiosity, a love for the ocean, wanted to save the ocean. Johnson really wanted to see conservation of the lagoon and the ocean. And unfortunately, they all passed away. They passed away 81, 83, and the direction of the institution changed a bit after that. But these are the ones that started it all. And as it turns out, the institution they founded, to my knowledge, was the only marine laboratory on the planet Earth that operated 3 ocean-growing vessels and 3 deep-sea submarines simultaneously at the same time, along with a fleet of remotely operated vehicles, and went to all the oceans of the world, Pacific, Atlantic, Mediterranean, Gulf of Mexico, all around the Caribbean. Our ships even went up the Amazon. And and all the Great Lakes. I went through all the Great Lakes as well. And of course, they're not there any longer. They disappeared some time ago. This is the way the submarine looked when I went down in 1980. You could see, we have a pointer here, I guess. Is that this one right here? Okay. Okay, have to hurry. Anyway, this camera, you just saw the footage that John showed in the film of the black and white images. This camera could shoot the fish swimming around a reef 300 feet of water an hour after sunset. So typically, the way I would make my dives, there were no lights. We actually wouldn't have these lights on. We just go down in the dark, sit on the bottom, let the fish get used to the submarine, and they'd come in and do whatever they're going to do. So we actually were able to watch them in their behavior. The characters in this play that I'm going to emphasize here are the ones that really own that reef. This particular group was the groupers and sea bass family. They've been divided into two families now. Are some of the largest fish on the planet. And that Warsaw grouper, which you saw in the film, is in a group of deep water groupers. They go all the way down to 2,000 feet, by the way, and get up to 500 pounds. What we now know about these fish is they live to be 100 to 150 years of age. So that grouper that you saw in John's film could have been well over 100 years old. These groupers in shallower water don't necessarily live that old. The coastal groupers, such as the Nassau grouper, red grouper, and Goliath, which you might be familiar with, are don't live that long, and actually are more not out in the Oculina Reef. The speckled hind is. This particular group of fish, groupers, I call the ubiquitous groupers, the gag, the scamp, actually can use a lagoon as a nursery. And the gag commonly, it needs seagrass. The gag grouper needs seagrass. And then these are the smaller, they used to be in the same family, but now they're in the sea bass family, the black sea bass, and the basslets here, which are very colorful, very small fish. These outnumber all the other fish out on that reef, these basslets. One thing they all have in common, they all start off as females and then reverse sex to males. And so we'll talk about that reproductive biology. The one that doesn't do that is a tattler. That's both male and female at the same time. It's a simultaneous hermaphrodite. And they have a little bout to see who's going to play the role of male or female first. So we still don't know which role is first. Then when a few minutes go by, they reverse roles. So the same fish within a few minutes will play the male role and also the female role. And we have belted sandfish on shallow reefs. It's the same, right out here, it's the same thing. All the others start off as females and go to reverse sex to males. Now out on the reef, the fish are distributed based on microhabitat choice. The scamp are usually in around the coral. Gags typically were up in the water column over the reef, and that large Warsaw would meander around the reef itself. And as I said earlier, the most abundant, these aren't sardines, these are basslets, these guys, schooling by the thousands over the reef. And this is the only place you're going to see them. You don't see them in the shallow water reefs, or you don't see them in the mid-shelf reefs, just out there. And we know that this guy, this is an alpha male, super male, that if you, and he has a harem, 20, 30 females. If you take him away in the aquarium, away from the females, female immediately starts changing sex, and within 2 weeks is a male. It actually reverses the color to the male color you see here. That's happening out here on the reef. If we sit there in the submarine and watch carefully enough, you'll see the males displaying to the females. This actually is a photograph on a Pacific reef. You can't go into many shallow Pacific reefs without seeing these antheids schooling over the reef. Here you have to go to 300, 250 feet to see that. And here we see these harems along the Oculina Coral. And then they reverse sex as the males disappear. They also disappear by the amberjacks eating the males. And I've watched the little tunnies come down from the surface on a clear day. You can see 250 feet come down and eat these little basslets. So and this is school. This photograph was taken. Well, that photograph was taken when we were studying this. These little tunny were feeding on the antheids. And the amberjack will eat them as well. The largest fish out there is not the amberjack, but this guy. This is a Warsaw grouper. As I said earlier, they might live to be well over 100 years old. And this is our one that was our sort of our mascot. It has a scar where a shark apparently had tried to take a bite out of it on the side. And this fish actually made friends with John. And you saw John on the coral table there measuring. You see on the poster over here, he's measuring his coral, and he has a caliper in one hand. And this fish actually took that caliper out of John's hand and had it in his mouth. And the way John relates it, he turned around and took it back out of his mouth. He needed to measure his corals, give that back to me. And I think they did it a couple times. Anyway, this guy really, I think, liked John, wanted to know what he was doing over there. And one day I was out on the reef, and he laid down on top of the submarine. I turned around, and this big eye watching me inside the submarine. And I said, my gosh, it's sort of frightening to see that you're being observed by something. This guy went down in deep water and probably using mixed gas and killed a Walsall grouper. Now, and there are people that have done this around the country. In fact, I have the skull of the one I was just showing you because somebody did catch it. But what he doesn't understand is this fish could have been an egg that was fertilized when General Custer was being massacred by the Sioux Indians in the 1870s. It's long before cars, long before airplanes, that he could have been out on the reef. Snowy grouper lives pretty long, an aged fish as well, and it's out there. And we think it spawns further down the slope, not on the reef itself, but we see them commonly there. And they have color patterns that they change. And one fish that we really were curious about when we saw it there was an undescribed species, the bargrum. Didn't have a name on it. And this is what it looks like. And somebody finally described it about 8 or 9 years after we've been diving out there. But I don't see this fish out there anymore for some reason or other. This is in the drum croaker family. It's akin to the spotted sea trout, black drum, that group. And another one I don't see very often out there is the speckled hind. This is the juvenile color pattern of these adults, and we know that they were spawning out there. We actually see the group here. There's several speckled hind, at least 9 in this, and they were interacting with one another. This black sea bass spawns out there too. Now, I have to explain using spotted sea trout here that all these fish are releasing their eggs up into water column. And they're fertilized typically in the water column. The males, females go to the surface at the same time. And I actually watched that. Every fish on that reef went up to the surface in 250 feet of water one day while we were out there. And then the larvae develop and drift with the currents. Then they hunt for, in the case of the spotted sea trout, it's hunting for seagrass to settle in. There's got to be a habitat for the juveniles so they can be protected from predation, but also have enough food to grow fast. They want to grow as fast as possible, and that's the life history strategy. Now, in that direction, about 36 degrees north, 27 miles from where I'm standing right now, where's the Blake Library, is Jeff's Reef. By the way, Jeff's Reef is named after Jeff Prentice, one of our sub-pilots, and the man sitting next to him was that old man, Seward Johnson, that I showed you earlier. And they ran into the reef out there in 1973, 74, running those transects John was talking about. So if you spawn on this reef, your egg is going to be carried, and then there are these eddies that come off the reef all the time. And once you get inshore, you have a southward current going south. So this movement of water from the Gulf Stream onto the continental shelf is what all these groupers are betting on. Their eggs and larvae have to come into the lagoon. So Mark Perry and I went out years ago hunting for seagrass. We didn't find any, but there was a bright green gag grouper that just came through St. Lucie Inlet hunting for seagrass. And that's its key habitat. This is a nursery for these guys. They'll grow as fast as they can so they can go back out in the continental shelf. And unfortunately, they've disappeared from Jeff's Reef. It's fished so hard now that there's no gag out there any longer. And what we found before they disappeared was that the gag tagged off South Carolina. Females actually migrated down to Fort Pierce and mated with the males down here. and then move back. But they didn't move back right away. They meet in inshore water, just the females, and they'd interact with one another, change colors and everything, and then one female would change to a male. When she changed to a male, which took about 2 months, then she stays on the reef. The males don't really migrate very far. The females can migrate hundreds of miles. And of course, they outnumber the males considerably. And the color patterns we worked out, we published this about 1992. These are females. These are the males, the black belly male. And in this photograph, this was taken over Jeff's Reef about 1980. You could count about 27 gag in that one photograph and they aren't there any longer. And they aren't a small fish. This is a male. This is a female. This is the male over here with black belly, and that's the female. And this is in the lagoon. This is what they look like when they come in. You see, that's a hand, so it's small. And then the scamp also goes through this color phase changes depending on, and they don't stay in this phase. They can go within seconds. These color patterns here, and this is a male displaying to his harem of females down here. Again, a male up here with the spots, and then he can look like this a few seconds later. These are females down here. So you got to sit there and watch these guys, see what they're doing. Here's a male diving on a female in a harem. There's several females there. You take that male away, and then the female, who's the top female in the group, has to take over become a male. She'll do that in about 2 months. And so here you see a harem male and the female, the scamp. Scamp's more closely associated with the coral because it's a smaller grouper, and I've watched the other groupers try to eat the scamp out there. I'm not mentioning anything about the blue angelfish, and you saw it in the film, but the blue angels change sex too. They start off females and go male, and they're also spawning out there. And so are the black sea bass and the speckled hind. You see there. It's a major spawning site for these fish. So what we decided, we proposed to look at the amount of pressure the fishermen are putting on this, because the fishermen were coming out and just catching all the groupers in the reef, and it was illegal to do that. And they still do it, by the way. So we thought we could track the activity of fishing boats, the fish, and divers with sound. So we were funded for several years to do this, both by NOAA, NASA, and the Fish and Wildlife Conservation Commission. And this is, I actually had Carrie Dillon, who's a local diver, help me put these things out. And this is when I was at the Kennedy Space Center for 5 years. NASA and NOAA funding built these units for us. And what we showed was that we could recognize the divers, certainly, and the bubbles. We could hear bubbles off a scuba tank a mile away. We could hear regulator breathing sounds about 100 yards away. And we could tell by the way the diver was breathing whether they were in trouble or they weren't. And we also could tell the brand of regulator that they were using to breathe out of. And we could associate the boat motor sound with the registration numbers on the boat motor. So we could tell every boat that went through Fort Pierce Inlet just correlate their numbers with the sound of the motor. So we could tell which boat and which boat owner was on the reef. Now the Navy's done this for decades, but we're showing how you could do all of this with a simple little hydrophone and an acoustic unit. And if you put out 3 of these, you could tell exactly where the boat was, exactly where the diver was. You would know precisely where they were. And we did all this 20 years ago and showed them. And we actually started in shallow water. This is the Goliath grouper on the bull shark barge out here. We showed that we could hear the Goliath grouper and the sounds they're producing and put tags on them as well. This is a unit we built at Harbor Branch that we could stick there. We could stick these units all the way down to 3,000 feet listening to the fish. And we did. In fact, this is Kerry Dillon over here diving. He's decompressing after making a mixed gas dive on Jeff's Reef, putting this unit that was down there 3 years, as you can tell. And what we were able to do was to determine the sounds we could hear on the reef, how far away we could hear a boat. We could hear boats easily 5 miles away. And a trawler produces a huge amount of sound, so we'd know where a trawler was there or not. Unfortunately, they never instituted any of this. And I noticed when I was at the Cape, I attracted a lot of interest from the Navy. The Navy has submarines going by here all the time. So I think the Navy was afraid that I'm not listening just to groupers, that I might be listening to submarines or something. And these are the guys at NASA that helped me out. Steve Van Meter, who is under the scrub jays here. This is his new life as a professional photographer. Mike Lane helped put the Artemis spacecraft out all around the moon. And all these guys, I think, are retiring now. And we used the space shuttle ships to recover our instruments and put them in between space shuttle launches. And it worked real well. But I have a feeling that they didn't want to institute it. So it can be done. And I wanted to point out that that was federally funded and state funded, and nothing happened. So it's up to this little guy, it's up to the people to do something at a local level. And that's what Sherry's doing, that's what Mark's doing. That's the way that we're going to have to get things done, is with you, and can't depend on the government to help us out. And John, I've been trying to do that for years. Thank you.
Hold on to that. That's good. Give it up for Grant and John. Thank you so much. Appreciate it. They're gonna. We have maybe time for maybe a question or two. It's about 7:45, and they do kick us out of here at 8 o'clock sharp. So, John, would you come up, please, and recognize? I also want to recognize that we have Jim Moyer, our Indian River keeper, in the room. Jim, with us. Also, Ed Killer's in the room. Ed, you're appreciated with Florida Sportsmen. And I saw Catherine, I believe, Catherine Udell, she's with Oceana, a great group that nationally protects these kind of environments. So, and of course, Sherry from the Conservation Alliance of St. Lucie County, and many others who, of our community, you all have helped protect. And that's why we leave that slide up here, is because it's so important. Many of you have already signed the petition, which will go to the Secretary of NOAA, all the important folks in NOAA who are about to make that decision on that particular amendments that would open up that to trawling. If you haven't, we're going to be passing out on your way out these small pamphlets that have the QR code. You just scan it with your phone like you're taking a picture. It shows you the website. You go right to our website. You can sign it online. It'll be delivered online. And we need to spread the word like this, and that's why we record this program. So spread the word, go online, get us signed on this petition, help us to stop this destruction of this beautiful habitat that we have here. So let's, we can field maybe a couple of questions. If somebody has a question, yes, right up here in the front. So when is the final vote about to take place, or is going to take place? John? Yeah.
I'm not sure. I mean, it's been voted by the South Atlantic Fishery Council back in December. They approved it. Then it was supposed to go to the Department of Fisheries or Department of Commerce. That happened in April.
Right.
And I sent a letter to the person at the Department of Commerce explaining the problems I had with Amendment 11 and 12. He never responded.
Yeah, so it's with NOAA right now, NOAA Marine Fisheries, NOAA Fisheries, and that's who this correspondence and petition is going to. They have to either approve or disapprove of this amendment. Even though the South Atlantic Fisheries Council approved it, It still has to be approved by NOAA and put into law, into effect. It's an amendment to the fishery management plan for both coral and shrimp. That's the way they're doing this. So we're going to keep tuned to the Federal Register, obviously, when this comes for a vote. But not only is it going to the heads of NOAA, the secretaries and all are doing that, who are going to consider it, but we're also sending these letters to the congressmen. Our congressmen from Florida and other districts all around need to understand they need to lobby the agency, namely NOAA, Marine Fisheries, to stop this amendment. So congressmen need to tell them. So we need to tell congressmen as well as the Secretary of Commerce and NOAA Fisheries. Any other quick question? Yes, ma'am. The question is, was there adjudication on the trawler that they caught? They caught the trawler, the one trawler that was on, so.
I'm not sure what happened to the trawler. I mean, of course, they said they didn't do it or something. So they got the tracking record from the ship showing it within the protected area on top of the Oculina, Jeff's Reef, on top of Jeff's Reef. They found that. What they did to it, I don't think a lot. I think they get a slap on the wrist.
Oh, you heard about that? She's saying that there was something about the money was taken and held in fair market. It was on the slide. So maybe they did, litigate them. Maybe they did fine them or process them through this process. And hopefully that was just one case, though, probably out of a lot that have happened. All right. Well, yep. We'll take 2 more or 3 more. Jim in the back. Yes. Both amendments, both 11 and 12. Both 11 and 12. 11 is the coral. What's that? That's right. The amendment is to the fishery management plan. The 12 is the amendment to the fishery management plan for shrimp fishery. Amendment 11 is the fishery management plan amendment for coral and coral reefs and live hard bottom. So those 2 amendments together are what's being proposed that would open up the fishery, the shrimp fishery to the Oculina Reef. Yes, Catherine, and then we'll go over here.
Oh, wonderful, yes. We are speaking to the national organizations like Oceana, of course, Marine Conservation Institute, and the National Resource Defense Council. And we are looking at legal options. What we'll do is include you in the national group and their particular staff that are talking to us. We kind of got a core going. So there are some evolving strategies. And so yes, let's get.
There you go. Good connection. And then any others in the room too may join on an amicus brief. Maybe a couple more? Yes. Yeah, go ahead. The questioner is about assuming commercial fisheries are against all this, or commercial fisheries against, us opposing the amendments, you mean? Or they want this to happen?
You would think they would. Yeah. But unfortunately, we still have fishing of the reef illegally, both by charter boat captains and other fishermen locally. And I found this out through my conversations with colleagues in the fishing community. Oh, that's my favorite fishing spot, you know. So, and once you bring a grouper up from 300 feet, he has problems. And what I've done with this submarine actually is try to decompress them, bring them up slowly, and it still doesn't work. With the snowies, the stomach air bladder comes out of his mouth. The groupers are particularly sensitive to that. I've brought wrasses up from 1,000, 2,000 feet, and they live just fine, but groupers don't. And this is a grouper reef, and it hits the fishery really hard. It really does.
So besides the shrimp fishery, it's the grouper fishery, but mainly it's this rock fishing industry that drags the bottom like that. That's so destructive that we're trying to. They're the ones that have proposed this amendment to open up for rock fishery. Maybe one or two more. Yes, sir.
Now, is it on this coast or in the Gulf where they stop grouper fishing?
I don't know where they stopped grouper fishing necessarily, whether it was.
I heard a couple weeks ago.
Well, there are laws and seasons for managing the grouper fishery, and they usually take the spawning season off limits, which is usually winter into early spring. And it's different in the Gulf than it is over here.
So
And it's true with many of the fish.
You might have heard. Maybe one more or two more questions. Yes, sir. That's it. The question is, how much money do the rockfish shrimp fishery want to make, you know, for this? How much do they expect?
And that's a real problem. Unfortunately, within the South Atlantic Fishery Management Council, which controls all recreational and commercial fishing from Carolinas through Florida, the council is pretty much run by the bottom trawl fishers. And so they're making the rules here. Yeah, it's very small. It's a very small fishery, primarily out of Titusville, primarily one family that kind of runs the whole thing. Just a few fishers.
Yeah, and name names and take places, but yes, here and then back to the Todd, and I think we've got to wrap it up. Yes, sir.
Doesn't complain too.
Mm-hmm. Yes. The comment is about the fact that it's the penalties in the law that says if you're fishing illegally in there, then you may get your boat might get confiscated, all your fish might get confiscated, everything, which is the case, I believe. If they enforce the law, then that would be the. Yeah. But if he can get away with it, he might not care either, that he can just get away with it and sell his catch for a top dollar. It is a risk. It should be a high risk. Yes, sir.
We spread a rumor that every boat that left Fort Pierce Inlet, we'd know whether it went to Jeff's Reef by the acoustics. They didn't fish Jeff's Reef for a couple of years.
It just kind of spread. Brilliant. One more, Todd, in back. Yes, sir. Calico scallop. Were calico scallop out there on those depths in the reef?
We used to do a lot of work with the calico scallopers out of Cape Canaveral. And most of the scallop beds were shallower, like 100 feet to 150 feet. You'd see big mounds of scallop shells. And then the fishery overfished them. They left the scallop shells inshore on the beach instead of putting them back in the water for the baby scallop to grow on. So the fishery kind of collapsed. I never saw any fishing on the deepwater Oculina reefs for scallops.
Yeah. So it's kind of ironic that that NOAA, who back in 1984 designated this habitat of area of particular concern, 1984, is now the same agency who's considering these amendments to open it up to this destructive activity. We just really got to do what we can. Again, I appreciate you coming tonight, learning so much more about the reefs, and please pick up one of the flyers on the way out to get the QR code. Go to the website. If you haven't signed the petition, there's one back there we can get on sign. Thank you for your participation and your action, taking action. And thanks again to our scientists. Appreciate it.